So oftentimes we have to be careful when we're deciding whether or not we want to use the normal CDF formula or whether we're using the inverse norm formula. So let's just remember the difference. When should we use the normal CDF? Well, when we're given the z-score, for instance, or equivalently we're given the mean, the standard deviation, and the x value. When we're given that, then we're going to use the normal CDF to find the probability. On the other hand, when do we use the inverse norm? So that's when the percent or the area or the probability are given to us, and what we're trying to find is the z-score. Or equivalently, if we're not using the standard normal distribution, it may give us also an x value, so a value of the variable. In this example, the completion times to run a road race are normally distributed with a mean of 190 minutes and a standard deviation of 21 minutes. What is the probability that a randomly selected runner will finish the race in less than 150 minutes? So here we can imagine that in our distribution here we have 190 for the mean and a standard deviation of 21. So if we go down and we add 21, 190 plus 21 is 211. Add 21 again, it's 232. And add 21 one more time, and we get 253. 3 standard deviations above. And then if we're going the other way, 190 minus 21, we have 169. Subtract 21 again, we have 148. And then subtract 21 one more time, and we have 127. Now, if we're looking for the probability that somebody will finish the race in less than 150 minutes, which we can imagine would be somewhere around here, we're looking for the area of that region below 150. So that probability that x is less than 150, notice here I'm using the x instead of the z variable, because now I'm going to, instead of computing the z-score that goes with 150, I'm just going to enter the different mean and standard deviation into our normal CDF formula. So in this case, the lower was -1 E99 since it goes down forever. Our upper would be 150. Our mean was 190, and our standard deviation was 21. So we enter all those values into our normal CDF. And we get something around 0.0284. What percentage of runners will finish the race between 205 and 245 minutes? Now notice that in this case we're finding what percentage of runners, but essentially that's a probability question. We're looking for the probability that somebody is going to be between 205 and 245 minutes. So again, we'll just use our inverse norm, or sorry, not our inverse norm, our normal CDF formula. The lower bound of 205, an upper bound of 245, and then the same mean 190 and standard deviation of 21. So second distribution, normal CDF. Here I'll put 205 for the lower bound, 245 for the upper bound, 190, 21 for the mean and standard deviation like before. And so that'll give me something around 0.233. So in our picture here, we would have the same labels on the x-axis, so I'll avoid writing that again, but the idea is that between 205, maybe about there, and then 245, maybe about there. I'm just roughly estimating where those values would fall here on the graph, but there we're finding the area of that region. There would be the percentage of runners that fall between 205 and 245. But now, because it's asking for percentage, we should convert this decimal to a percentage, which would be about 23.3%. A construction zone on a highway has a posted speed limit of 40 miles per hour. The speeds of vehicles passing through this construction zone are normally distributed with a mean of 46 miles per hour and a standard deviation of 4 miles per hour. What percentage of vehicles exceed the speed limit? So we can imagine here, because the mean is 46, standard deviation is 4, so let's go up by 4 here on the right side, and then we'll go down by 4 on the left side. So what percentage of vehicles exceed the speed limit? Well, 40 was the speed limit, and that falls right about here. So the way we'll answer this is we'll try and find the area of this region that's to the right of 40. So we want to find the probability something is that their speed is greater than 40. So normal CDF the lower bound of 40, upper is 1E99, the mean was 46, and the standard deviation was 4. So here, when we compute with the normal CDF, it's something about 0.933. If the police wish to ticket only those drivers whose speed fall in the upper 20th percentile, what is the minimum speed of a driver that will be ticketed? So the 20th percentile would be the value that corresponds with 20% of the speeds falling below it. So wherever that is, here we can imagine, maybe right about here. So we're going to try and find that value, where the area below that value is 20%, or the area would be 0.20. And so here, because we're looking for the area, or I'm sorry, we're looking for the z-score, or in this case, the x value, given the area, we're given the area, so we're going to use the inverse norm. So the area that we're given was 0.20. The mean was 46. Standard deviation was 4. In this case, to the left of that value. Oops, to the left. So here we'll go to the distribution menu, inverse norm. Area is 0.20. The mean was 46. Standard deviation is 4. To the left of it, we have 42.63.